Well, in this video, we're going to be talking about obtaining information from or about the graph of a function. And for the next few videos, actually, there's a few examples here. One of the things that I enjoy about this section is there's really very little work to do. When you look at all of these, you might think, oh, there's a lot of work. But no, there's very little work to do. There's more thinking involved. And so you have to think and understand what the terminology is, and I'm going to do my best to explain the connections between what you're seeing and what you're supposed to know. So starting with A here, we're trying to find f of 0. Well, we should know that f of 0 really means what's the y-coordinate when the x-coordinate is 0. So we have the graph of f of x, and again, we're trying to find the y-coordinate on the graph of f of x when the x-coordinate is 0. Well, as we see here, the graph goes through 0, 0, so f of 0 is equal to 0. And then, likewise, we're trying to find for f of 6, we're trying to find the y-coordinate when the x-coordinate is 6, and we see that that is also equal to 0. And so part B, find f of 2, so same kind of thing. 2, negative 2 is a point on the graph, so when x is 2, y is negative 2. And then when x is negative 2, the x-coordinate is the one in the middle. That's the x-coordinate, the one inside the parentheses, I should say, not in the middle, but the one inside the set of parentheses. The input always goes in here. The output is what you get out when you plug the x in. So you plug in negative 2 in, out comes a 1, hence the ordered pair negative 2, 1. So therefore, f of negative 2 is equal to 1. Part C is f of 3 positive or negative. Well, f of 3 is the y value. So we're being asked here if f of 3 is positive, then that would mean that the y value when x is 3 would be above the x-axis, which we can see it's clearly not. When x is equal to 3, the y value is negative. It's below the x-axis, and so therefore f of 3 is negative. So we'll just circle negative. Likewise, with f of negative 1, we're being asked what's the y value when x is equal to negative 1. Well, the y value clearly is above the x-axis, and so therefore, since the graph is above the x-axis, the y value is above the x-axis, and therefore the y value when x is negative 1 is positive. So therefore, f of negative 1 is positive. For what values of x, so we're looking for the x values, is f of x equal to 0. So these are the x-intercepts. Where is f of x equal to 0? Well, we see that the graph crosses the x-axis at 0, 0, 4, 0, and 6, 0. The values of x in those locations are 0, 4, and 6. And then for part F, for what values of x is f of x less than 0? Well, f of x being less than 0, that would be where the graph of the function f is underneath the x-axis. So f of x less than 0 is the same thing as asking, well, where is the graph underneath the x-axis? So it's underneath in between 0 and 4. 0 and 4. It's not underneath at 4, nor is it underneath at 0. So therefore, we don't include the endpoints by putting parentheses there. The domain of f, well, that's all real numbers, that all the x values that are used to graph the function. So the first x value is negative 4. There are no breaks in the graph. It goes all the way till the x value of 6. The range of f would be the lowest y value to the highest y value, and if there are no breaks in the graph, going from bottom to top, then we would include all the real numbers in between, the lowest real number of negative 2 to the highest real number of 3. So the range is from negative 2 all the way to 3. What are the x-intercepts? Well, we already talked about that. It's the same answer as, what was that up there? The same answer as E. That's where f of x is equal to 0. In other words, 0, 0 will include the x-intercepts here as coordinates, 4, 0, and 6, 0. What is the y-intercept? Well, it's the same as the x-intercept at the origin. There's only one y-intercept for any function. How often does the line y equals -1 intersect the graph? Well, you can draw the line y equals -1 as long as you understand it's a negative, it's a horizontal line. You can see that it intersects the graph twice. I was going to say 2 times. How often does the line x equals 1 intersect the graph? Well, x equals 1 is a vertical line, so it intersects the graph at one spot. And then for what value of x does f of x equal 3? Well, f of x is equal to 3 when x is equal to 5. So the point 53 is on the graph. F of x equals 3 when x is equal to 5. And finally, for what value of x does f of x equal -2? We can see the point 2, -2 is on the graph. So therefore, the x value when y is equal to -2 is 2. And there you have it.